Okay, good morning, everybody. My name is Mayo Castro. I'm the coordinator here at the training center. I'm glad to have you guys here. I want to welcome you guys officially to the United Brotherhood of Carpenters. I'm glad to see that everyone here has a goal in life, and we're gonna help you succeed with it, with your goals. Okay, make sure that you set goals that are achievable, one at a time. Don't try to hug more than you can handle. Okay, just take it one step at a time. This is the beginning, and you have a long way to go. But patience and perseverance will get you there. Okay, today my presentation is going to be in relationship to what your instructor already spoke to you about. It's about applying math, applying different instruments into the building trade. You guys are carpenters, and to me, you're the most important person on the job site. I have to have evidence to support that. How do I say that? Because from my experience, I could pull in my truck, in my work truck, into an empty lot. I could get a weed whacker. I could tell one of my apprentices, hey, let's clean up this area. There was a civil engineer that came, and he has a control point for us. He has maybe 2 control points. We're going to find him right now. And from there, we're going to build a structure. We're going to start setting control points. We're going to start doing layout for foundations. And why is this very important? Because remember, the foundation is the most important part of the building. If you start the foundation wrong, if it's a 1-story building, now you got a 1-story problem. But if you start the foundation wrong also, in a 70-story building, and you don't find out that that problem is already going on, you might be finding out that the problem is going on the 10th or the 20th floor or the 30th floor, and now you have to fix it. How big of a problem is that going to be, right? Huge. It's going to cost millions of dollars to fix that, or it could be just a disaster. So that's why applying math is important, and learning how to set these instruments that come all together with math. Okay, so we're always going to be working with numbers. But one thing is, I want to show you guys how to use an instrument. It's a layout instrument. It's called a digital theodolite. There's 2 steps that I use, and I'm using my experience. You might go out there, and there's more than one way of doing things. Your foreman might have a different way of doing it. I'm going to show you the most effective way that I know what works for me, and it has been working for 30 years. Okay? So I'm going to set a tripod. I want to show you how to set a tripod over a point, over a survey point. That's what I should be calling it. And then I'm going to set the digital theodolite over the tripod and over that point. That point right there that I have on the floor represents a control point that was given to me by a civil engineer. We have evolved, with times, we have evolved, right? Just like I showed you in this handout right here, okay? What I call evolution of surveying. Takes you from the history of how the Egyptians used to do it with ropes to instruments. Okay, so since there was some evolving on this, carpenters have also evolved. We don't use ropes. We use surveying instruments. Okay, so this is how it works. I'm going to give you just some quick names. We use builder levels, transit levels, automatic levels, laser levels, digital theodolites, and total stations. Total stations are connected to satellite. It's almost like playing video games nowadays. And you could set a whole structure and set all your points and set all your elevations by just having like a little iPad in your hand, and another instrument we call a prism, and you walk around, and it's a robotic total station. It follows you around, and you're reading, and you find your exact point, you mark it, and you keep going around. You can find thousands of points in that building, and then you can make structures happen like the Ram Stadium, or skyscrapers, or one-story building, museums. Anything can be built like that. Nowadays, they're built with total stations. But I'm gonna go back one step, and I'm gonna use a digital theodolite because I want you to learn some of the basics. You cannot jump into something that is so high-tech if you don't understand the basics. So, basic math fundamentals, basic instruments that will get me to the most intricate instruments. So I'm gonna start by setting a tripod. Let me show you. I'm gonna show you just a quick shot on the board. What I'm gonna draw is a bird's eye view. It's a view from above, as if a bird was staring down to this point. Okay, that's what I'm gonna do, because that's what you're gonna have in your hands when you start applying layout from a set of prints and transferring it to the floor. That's exactly what you're doing. If I look at a floor plan on a set of prints, I'm looking at it, and I'm gonna transfer it down to the floor. So I'm gonna give you an example of a tripod, and the way I do it is, this represents me, okay? And this represents one leg of the tripod, one leg here, one leg here. What am I doing is, I'm gonna set my tripod where I kind of position my legs around this leg. I can get my leg in here, my leg in here, get as close as I can to the instrument. That's why I don't like to use the two legs back here. To me, that works better. It allows me to step real close, and that leg is in between my legs. Now I'm right up at the instrument without hitting or running into my tripod. And if you notice, it's a perpendicular position. These legs are perpendicular to this one in the direction of my body. So I picture a T, a capital T or uppercase T in front of me. The top of the letter T is over here, and the other part is right here. That's how I want to do it. I want you to kind of think about it like that. Okay, I'm gonna now, that being said, I'm gonna first set the tripod over a point. So what I did is I placed a sticky pad in the floor with just one dot that I drew with my Sharpie. Okay. The main purpose of this, first of all, is what I told you. Now I want you to picture it now. I could step into here. My legs around this leg. I'm not running into the other two. To me, that works because I get closer to my instrument right here. Now, I have enough experience to where I can tell when something is flat, it's level. But but if you don't have enough experience, okay, I'm gonna check it like that. I'm gonna check it with a 90-degree angle. First, I want my tripod to be level across this way. So I place a torpedo level, and it's dead on. That's how good I am. Just kidding. But it's dead on this way. So now I turn it 90 degrees this way. Okay, it's slightly off. Okay, it's sloping upward in that direction, so my bubble needs to go the opposite way. All I do is now I just gotta move this leg, just a tiny little bit. That was it. That's all I have to do. Only move that leg that much. I check it one more time. Still that on. It was a minimal movement. And by moving this leg sideways, I took care of that. I already had it under control the other way. Okay? So the base of my tripod is now level. My next step is I was already kind of sighting my tripod. When I set it, I sighted. There's this little instrument here, and if you notice, it's like a pendulum. This knob right here, it's a bolt that is hollow in the center. I could sight down that bolt, and I see that dot right there. So I know I'm close, I'm within range, because I have about 2.5 inches or 2 inches of play right here. So if I place that right in the center, and it acts like a plumb bob, like a pendulum, I sight down, and it looks good to me. It looks like it's in the center of that hollow bolt. Okay? So now I can move that bolt. Now I use a plumb bob. I want to know how close I am, because I want to make sure that I don't have to do extra work. The closer I am, the more control I have of this. So I drop it right in the center of this hole in the tripod. I hold it right in the center. I'm sighted here, and I'm bouncing my plumb bob to stabilize it. I don't care about the bottom right now. I'm just sighting it here. I'm centered. I stabilize it. Now I let it go. I'm like, okay, I'm within 1/4 inch from that dot. So I know I have enough play because this is already level, and I'm that close from the dot. So I got that under control. The next step is to set my instrument. These instruments are pretty expensive. You have to use caution when you handle them. We usually try to either grab them by the handle and also by the base. I set them there. And I'm going to use the same method. I'm going to apply the same method, right? But in this case, let's see. Okay. In this case, what I'm going to do is I'm going to use the same method as I did on that. I'm going to set it where there's 2 knobs. There's 3 knobs to this instrument. I'm going to have 2 knobs there and 1 knob right here. Again, like a uppercase letter T. And I'll explain why I do it like that. From there, I make sure that I attach the instrument to my tripod. And if you notice in this, I gave you a handout. Okay. It says setting up a tripod. It says, it's this handout right here. It says Theodolite. And shows you how to set up a tripod, which I did my first step. Now this next step is setting the instrument itself, all right? So setting up a theodolite, right? Theodolite is the most accurate surveying instrument mainly used for measuring horizontal and vertical angles, locating points on a line, prolonging survey lines, finding difference of levels, setting out grades, ranking curves, okay? And tachonometric survey. So operation of setting up a theodolite includes centering the theodolite over the ground mark, which is my point on that sticky pad. Leveling of the theodolite. The operation is making the vertical axis truly vertical. Is known as leveling of theodolites. So what I wanna do on the board again, this theodolite is made up of two bases right here, the uppercase and the lower case. In the lower case, there's a bull's eye. Who knows what a bull's eye is? Okay, like using a bow and arrow, right? You try to hit the bull's eye at the center, playing darts, you try to hit the bull's eye. In this case, there's a bull's eye right here on the lower case of this instrument. So I'm gonna try to explain this in a simple way and how it works for me. It's like if you picture a plate, when you go to a restaurant, if you get a plate, a paper plate or a regular plate, and that plate is flat, but it could rotate, right? You could do this. If you put a little bit of water on a plate, and you start going around, that water is gonna follow the edge of the plate. If you go too much, it's gonna spill out. I want you to kind of think about it like that. So, in this instrument, I'm gonna try to draw something that represents the lower base of this where the bullseye is. So that, it's gonna look something like this. I'm gonna exaggerate. Okay, and then there is the three knobs. Two here, one on this side. So I'm gonna represent this. This represents the three knobs that I'm talking about. Those knobs are gonna help me level the bullseye first. I need to set that bullseye in the center. So the bullseye in this case is right here in this corner of this triangle. So the bullseye right now is like right here. And it looks like that. And there's a bubble. There's a bubble somewhere in there. The first thing I want is, when I was giving you that example of that plate, spins around like this, that's what I'm thinking of doing with that bubble. Brother, please, if you can stay awake, I know it could be a little boring, but please stay with me, okay? This bubble, the most important thing for me right now is to make that bubble travel around the edge of the bullseye. I don't care if this bubble travels around on this side, along this edge, or the opposite way. Okay? I'm gonna move the knobs, because right now, if I look at my bubble, right now my bubble is right here, almost where I had it, right here. Okay? I wanna make it travel around the edge. I want my bubble to either end right here or right here. So when I'm standing in this instrument, I'm gonna make that bubble go around. It doesn't matter where it ends. I don't care if it ends on that far from me or closer to me. But I want it to be, I'm standing here, I want it to be either here or here. Not anywhere here, not anywhere here. There's a reason for it. So who heard of the saying, the rule of thumb? It's a rule of thumb. Ever heard that saying? It's a rule of thumb. Rule of thumb comes from instruments like this back in the old days. Thumbs in or thumbs out. That's where that saying comes from. Oh, just use the rule of thumb. Thumbs in, thumbs out. By doing this, I'm going to make that bubble travel around this bullseye. So I'm going to do that now. Okay. So in my case, I was going thumbs out. What I did right now, I made this bubble move, and it ended up right here. So I'm gonna get rid of that bubble now. My bubble traveled around, and it got here. So now I have it in control. Now I want that bubble, again, to come my way, because the bubble right now is away from me. I want it to come towards me. I'm standing here. I want this bubble to come straight this way. So what do I use now? This knob only. That's why I was working perpendicular. I already controlled this. Now I'm going to control this. I control the bubble to travel around this in any direction. It's fine, but I have it here now. Now I want the bubble to come this way, which means my instrument's base is sloping, is higher on that end, and it's lower on this end. I want this end to go up so that the bubble travels my way, and it gets to the center of this. So now all I do is I just use this knob. I stare at the bubble here, and I only use one knob. I'm moving the base, and I'm gonna make that bubble. I can see the instrument moving, and I'm gonna make that bubble come towards the center. Okay, my bubble is, what I did right now, if you saw, I only used one knob, and my bubble has moved and is right here now. It's inside the bullseye. Do we have any questions so far? Good. You understand the method that I'm using? Yeah. Control it horizontally first, this way. It's all about 90 degrees, right? It's all about a right angle. If I control this instrument and I set it and I turn it 90 degrees or a right angle and it's good, then I know that if I keep going 180 degrees, it's gonna be good, okay? Once I make it all the way to 360, it's always gonna be good. If I know that it's good at 90, at a right angle, it's gonna be good all the way around. So I already know I did my job correctly. But there's the second part of this is I already have the bullseye center. But now I have to set the most important thing, which is my upper portion, my instrument. Okay, for that, there's a regular vial, like for any torpedo level, 2-foot level, 4-foot level, 6-foot level. It's a vial just like this one. Okay? So what I'm gonna do is, I'm gonna set that vial, is right here on the front, on the top. I'm gonna send it parallel with this two knots. I'm gonna control that vial, I'm gonna center it. I'm gonna get it to the center by using these two knots and using the rule of thumb again. Okay? So if I look in here, okay, my vial is, just to give you a quick example right now, this represents that vial. There's this 2 lines right here. Right now my bubble is about right here. I want my bubble to travel that way to be in the center of that. So I'm gonna use the rule of thumb. I'm gonna give you my back for a minute here. Okay, I'm here. I want the instrument to go that way. I apply the rule of thumb on here. Either thumbs in or thumbs out again. I have enough experience so I know that for that bubble to travel towards the right, I gotta go thumbs in. Remember the rule of thumb, okay? Bubble is gonna travel to my right, thumbs in. Bubble is gonna travel to my left, thumbs out. Take notes if you want. This is gonna help you for a lifetime. Okay, bubble, move to the right, thumbs in. Bubble, move to the left, thumbs out. So I move that bubble. These are very sensitive instruments.
Can you repeat it one more time?
Yes, of course. For the bubble, if I'm facing the vial, if I want the bubble to move to my right, I go thumbs in when I apply the rule of thumb. If I want the bubble to move to my left, I apply the rule of thumb and thumbs out to move to the left. So see how there's some interesting things right here? You hear that saying, oh, hey, it's a rule of thumb. Well, that's exactly where it comes from one of the instruments that a carpenter uses. Okay, so now look, my bubble in my vial right now is dead on center, so I'm gonna erase this. My bubble right now is there. You can't see it, but I can see it here. Okay, so now, since I have this under control and my bubble is in the center, all I gotta do now is I turn it 90 degrees, a right angle. I turn the instrument 90 degrees. Now it's perpendicular to this too. We all know what perpendicular means?
Yes.
Okay? This line is perpendicular to this line, like a T, all right? Or a 90 degree right angle. So I just did that with my instrument. It was running parallel with these two knobs. I got my bubble under control like that. I turn my instrument 90 degrees. I stand over here. My bubble now wants to travel to my left. So how do I turn it? Thumbs out. Okay? Only this one. Only this knob. Thumbs out. Thumb out only on that knob because I already have this under control. So now, just a little bit, very sensitive, okay? My bubble now that, I just turned my instrument. So my instrument was this way. I had it under control. I turned my instrument this way. I just barely touched that. Had to go to my left. It's there now. So now I go back to the original position like this. I check my bubble one more time. It's dead on. Do I need anybody to step up and see it? Come on, I want to bring one of you guys, at least one. I want you to see this bubble there. First of all, I want you to notice the bullseye. Is that center? Dead on. I want you to see that bubble there. All right? Dead on in the center. I turn it 90 degrees. Let it move around a little bit. Takes a couple of seconds and then it stabilizes. How is that?
Perfect.
Okay, so now I could go, I know now that it's right because I could go 180. And I want you to step over here. I could go in any degree now. It's all going to be good. Once I establish my control at 90 degrees, at a right angle, I know I'm already there. There's a lot of people that will continue to circulate and circulate. Brothers, all you need is 90 degrees. That's it. If your instrument is well calibrated, 90 degrees, that's all I need. I'm not going to be wasting my time because I'm costing my employer a lot of money. Witness to that? Okay?
Witness.
Now that I have that under control, it's time for me to set my instrument over my point. Okay? So there's this lens right here where I can stare into there and I can see that dot. It's like a scope. You have to focus. You have to do I can see the crosshairs or the bullseye. When I stare in there, I'm gonna see how far I am. Okay, I gotta focus it. It looks blurry, but I can already see it. Oh my God! All right, I'm witness it again. Tell my audience how much I'm gonna have to move that.
You have to move it to the right, about a quarter inch.
You think a quarter? I think more like a 16th of an inch. But let's try and move it. So the way I do it now, I grab the base carefully and then I stare at that dot. I loosen the base a little bit, and it's gonna be very minimal movement. Okay, let me loosen it up a little more. Okay. wanna say we were both at about an 1/8 inch. Okay, I tied this back up.
I said a quarter, I meant to 8.
You meant to me, that's good. Hey, see, you were close enough, and this is your first day as a carpenter, right?
Bullseye,
Dead on?
dead on.
And that's how we said a digital Theodolite. That's what you see civil engineers doing out there over an established point. And that's what you're gonna be doing in the future. Doing layout, building structures, and setting instruments like this over an existing point of control. That existing point of control is usually given to us by a civil engineer, but don't underestimate yourself. Nowadays, us carpenters are capable of doing everything. We have instruments that can do that. We can set our own control points. Okay? We don't have to rely on anybody else because now we're connected to satellite. The next time around, I will be speaking to you about total stations, okay, which is now, it's a robotic total station. That's the next level, but I want you guys to make sure that you go to all these trainings and learn all about this because you're gonna be building on your future. Okay? Thank you. Appreciate it.